In this video, we want to take a look at test of statistical hypothesis. Now, we may want to get a pen and paper to jot down some things. First of all, this topic is not a topic that you just listen to once or you watch once and you understand everything there is to it. It requires patience. So, here we go. Now, hypothesis is a reasonable claim or an assumption or a suggestion that is made about an unknown population parameters. We have two types. The first one is the null hypothesis. We use H0 to denote it. Null hypothesis is a hypothesis of no difference. This is a hypothesis that says that there is no significant difference between observed value and assumed value. So we use H0 for it. The second one is an alternative hypothesis. We use H1. Some textbooks will use HA for it, H subscript A or H subscript 1 for it. So this is a hypothesis of difference. It says that there is a significant difference between observed value and an assumed value. So the next thing we can talk about here is level of significance. We use alpha to denote it. Alpha. So if we have a distribution curve, this area is what we call alpha for one tail test. Or if we have this other side, alpha, this is actually a one tail test. A one tail test is a test that is directional, that has only one critical value. You can see this place is called the critical point. The value is gotten from a table, a statistical table called critical value. So critical point. The whole of this distribution equals 1. So since this place is alpha, it means this whole unshaded part is 1 minus alpha. And this level of significance is in percentage. So when we say level of significance, its definition is the committing of type 1 error. And what is this type 1 error? The type 1 error is committed if we reject the null hypothesis when it is true. Type 2 error is when is committed. I beg your pardon. Type 2 error is committed if we accept the null hypothesis when it is false. So that these are the two. How do we now know when it is one tail test or when it is two tail test? When it is one tail test, H0 says that the population mean is equal to mu naught, and H1 will say that the population mean mu is less than mu naught. So whenever you see this directional, so on the alternative hypothesis is where we normally know whether it is type 1 or type 2. So whenever you see direction, either this or this, you know it is type 1 error. But how we know we know that it is one tail test. How we know it is two tail test is if this says it is equal. Remember, H0 is always equal. Is equal to mu 0. And H1 says that it is not equal to mu 0. Then two tail test. When we see direction, one tail test. When we see no direction, two tail test. Because when we say it's not equal, it means it can be greater or it can be less than. Please be patient. Little time will get more understanding. So back to level of significance. If we say a test is performed at 5% level of significance, what it means is that alpha is equal to 0.05, because 5 over 100 is 0.05. It means we are 95% correct and 5% chances in 100 that the true null hypothesis could be rejected. So we are 5% wrong and we could be 95% correct. When we say 99% level of significance, we are saying we can be 99% correct, 1% wrong. So in a one-tailed test, we use it as this. In a two-tailed test, we divide it into two. Alright, so the next thing we look at is procedures. Okay, before we get there, if it's a two-tailed test, for example, if it's a two-tailed test, we have something like this. So this place becomes alpha over 2, this place becomes alpha over 2. Okay. So the next thing is procedures for hypothesis testing. Now, the first thing is to state the hypothesis, that is the null and the alternative. This is how we state them. The second thing is to state the level of significance. It is given in the question, either 5% or 10% or 1% level of significance. So if it's 1% level of significance, you state it. But when none is stated in the question, you need to use 5%. It is the universally accepted level of significance. The third one is to choose a suitable test statistic. We have different test statistics. We have the z-test. We have the t-test. In another video, we'll do calculations with them. We have the t-test. We have the chi-square. We have the feature test, and so on. So we choose the one. We'll state the conditions. When do I know that I'm going to use z-test? The first condition that I'm going to use z-test for the question given to me is that first condition that the sample size n must be large. When it is large is when it is greater than or equal to 30. So if it is less than 30, I'm going to use t-test. The next one is the population variance must be known. Population variance must be known. Another one is that the population must be known to be normally distributed. These are the three conditions. Once you see any of them in a question, you use z-test. So going back to the procedures, the fourth one is we determine the critical point. Critical point is always gotten from a table, a statistical table called critical value. The next point is to state the decision rule. The next one is to make the decision and then state our conclusion. So let's just use this question as an example. A random sample of size 49 from a normal population has a mean of 30 and a standard deviation of 8. Does this suggest at 1% level of significance that the population mean is less than 32? Now, how to digest these questions is that once a question starts, any information given to you is about the population. But the moment you see sample, then any other information given to you is about the sample. But this question now started with sample. So the information given to us is sample. Now, normally, it says a random sample of size 49. So sample size n is 49. You can see it's greater than 30. So we're going to use z-test for this question to solve it. Okay, from a normal population has a mean of 30. It means the sample mean x bar is 30. This sample has mean of 30 and a standard deviation. So the sample standard deviation is 8. Does this suggest at 1% level of significance, so alpha given to us is 1%, that the population mean, mu, is less than 32? So what we are looking at is to test whether this is less than 32. So because of that, H naught, the first step in testing hypothesis is state the level of, state the hypothesis. So H naught will say that mu is 32. And H1 or HA will say that mu is less than 32. So this is a one-tailed test. This is a one-tailed test. So the next thing is to state the level of significance. This level of significance is 1%. So 1%. And it is one-tailed test, so we're not going to divide. So 1% is 0.01, which is 1 over 100. So 0.01. So what it means is that we're looking for z value under 0.01. Now, the easiest way, we can go to z standardized normal curve. But the easiest way I teach students to do this is to check at the t distribution. T starts from level degree of freedom 1 to 29. But once you get to 30, you've entered z-test. So go to 30, that is infinity. And under 0.01, we go to infinity under 0.01. The value there is the z-test. That's the easiest way to look for z values. So 2.326. So 2.326. Some textbooks will approximate to 2.33. So whichever way. So now we've gotten the tabulated value. The next one is to choose appropriate test statistic, which is because we have that sample size is 49, we're using z-test. And the formula for z is that z is equal to x bar minus mu over sigma over square root of n. We have already mentioned the meaning, so we just fix the values. Sample mean 30 minus mu 32 over standard. Since this was not given to us, population standard deviation, we estimate it with the sample standard deviation, which is 8 over square root of 49. If we resolve all of this, we're going to get minus 1.75. Now, this value of z is plus or minus. So for us to, the next thing is to determine on the distribution where it falls. So if this is, here is 0, and here, this side is alpha, and remember critical point minus 1.75, sorry, 2, minus 2 point, because this is what we got from the 2.326, 2.3, I beg your pardon, 326. So here is 2.326. We now need to bring this value to put here to know where it's going to be. This area is called rejected region. This whole place is acceptance region. So the value we got, if it falls within here, we accept H0. If it enters here, we reject H0. So if this is 0, we want to bring 1.75. So 1.75 may be around here. So it falls under acceptance region. So we accept H0. So the conclusion will now be, since, another way to do it is, since z calculated is less than z tabulated, since this is less than this, remember this is plus or minus, we are not checking it in terms of magnitude, we are checking it in terms of, this thing just shows the direction. So since z calculated is less than z tabulated, we accept H0 and conclude that mu equals 32. That will be our conclusion. So please, we'll be doing subsequent videos to give detailed explanation on this. Please subscribe for my channel to get more of my videos. You can click the notification bell so you can get other videos when they are uploaded. Thank you.